Good evening. Hey, good evening. Janman,
Hello. Good evening.
am I audible? Prasanna, can you hear me?
Yeah, actually, I can.
Okay, great, great. Jahnavi, how about you? You are on mute.
Yes. Mhm.
Okay. So, just to start with today, right? Let us go with some like first to finish the basics of this, what is required for this particular uh, with data engineering. So, I hope Jahnavi, so you got some knowledge on Python by any chance or no?
Yes. Yes, I do have.
How strong you are in Python?
I think mid-level.
Mid-level means you know basics of Python.
Yeah, I know.
Okay, like I mean till the functions and
Like pandas, creating data visualization, like handling uh, data part.
so
So
pandas.
that,
Pandas are you familiar with?
yeah, yeah.
So how about PySpark?
Hmm.
No, right?
No,
No.
no.
Okay. Anyway, just let me go and start with pandas once again because just I want to recap what, and then we'll go with some basics first, and we'll finish them, and we'll jump into the actual data engineering and other stuff. Okay. Just give me a minute. I hope you're able to see my screen. So when I talk about pandas, just to recap, and you can also recollect so that it will just like a refresh for us. When I say pandas, generally there are some functions available to perform file operations in Python. But however, those file operations or functions, whatever Python is providing, are not that much strong enough to manipulate other file formats except text file formats. So that the text files I can easily manipulate using the Python native file related functions. But when I talk about data which is coming up like a semi-structured data like XML and then Parquet, Avro, these kind of file formats generally I cannot go and manipulate using the Python functions which are providing for file operations. So sorry. Okay, so this particular file related operations or data related operations, if at all I want to perform, I need to load the data into the Python environment. Generally, the Python Pandas is providing the data structure called data frame. So using this data frame, I can manipulate the data. Once my data is available in the data frame, I can manipulate this data by using different Pandas related APIs and functions. So what kind of operations which we can perform? We can do the data cleaning. And for example, assume I have a price column, item price column coming up with a dollar, which I cannot go and use directly to perform any calculations. So what I need to do, for example, assume you received a data with the item name, quantity and item price. but item name quantity, item name is in string and item quantity is numerical, but item price is supposed to be float, but it is in string format because of the dollar is available. If at all I want to find out all the items for which item price greater than $10, I cannot use this item price column, correct? No? Do you agree, both of you? The item price column need to be cleaned, right? Yes or no?
Right, correctly. Right.
So what I need to do here, I need to
Convert.
extract, I need to remove the dollar either or replace. That is one operation I can do. But I don't want to change the column. I want to keep the column as it is, but I want to generate a new column. Maybe assume I have maybe near to 3,000 rows are there, 3,000 items are there. But all these, for all these items, the item price column which contains dollar need to be cleaned and it should be converted into a float. But I want to generate a new column. Then what I need to do? From the item price, I need to select from the second position to till the end because dollar is in the first position, assume that. So from the second position to till the end, if I will slice it and then I can convert into a float and generate a new column. So that can help me to go and apply some numerical calculations on the new column because the existing column is a string column, just assume that. So this is basically one of the data preparation which we do, a data cleaning operation which we need to perform sometimes. And in some scenarios you need to handle null values also. So what is when by handling null values? So my data may contain nulls and I want to see how much percentage of null values are there. If required, how to replace them. I want to replace all null values in the numerical data with 0. I want to fill with 0. Or I want to go and replace all the like a string columns with a null with some fixed value, fixed string, like with no data like that. Then I need to use the Python pandas native functions which are available. And aggregation, when I say aggregation and grouping, this is basically which we already know in the database, which we perform like SQL aggregation. The similar kind of aggregation I can apply on the data frames also. And I can even apply joins like inner join, left outer, right outer, full outer. I can apply them. At the same time, I can apply all the group functions, whatever available in SQL. I can apply all of them even in pandas also on the data frames. But after you aggregated, you need to use the specific aggregated functions which are available on top of the object which you created with the group by. And apart from that, we also need to see how we can select the required columns or required rows, how to filter them, and how can I go and transform my data, how can I go and need to normalize the data. There are so many operations which generally you perform if you go to any data engineering project because the basic data manipulation can be done through the Python and also PySpark. But here Python pandas is just like a foundation to understand PySpark faster. That's why I just want to refresh on that. And coming to like pandas, this is the open source library similar to other libraries which will need to be loaded first and then we need to use all the functions of this library on the data. And this will be generally will be available by default. We do not need to install it. We simply need to load it by using the import command. The import pandas as PD. That is the standard syntax people follow in most of the projects. Once after it is loaded, the particular that alias PD we'll use and we call the respective functions of the pandas. Can we here we are calling a series. A series is a pandas column. We call a single individual column in the data frame. We call that as a series. A collection of series will become a data frame. So I can get a single series column as well as I can create a entire data frame also. So the data frame function will create a specific data frame from the data, whereas a series will create a single column that can be used to create another data frame also. It's just like a one-dimensional array. It will hold a group of values separated by commas. But the data frame is a two-dimensional labeled data which will have rows and columns, and which will looks like a spreadsheet, Excel spreadsheet with an index, row index, and the column header. So a data frame is one of the fundamental like uh, data storage variable that can manage a combination of data. So the index of row index will allow us to pick up the respective rows, and once your data is in data frame, I can do the row slicing and column slicing also. For that, we have functions available, LOC and ILOC. And coming to like creating data frames also is like we have different ways. But here I'm simply loading the pandas as PD, and then I am creating a dictionary here. This is a dictionary, right? I hope you know that, both of you. This is a dictionary enclosed in curly braces with name is one key and corresponding names and age and the city. So whatever you see, this is a dictionary with name data, and we can simply convert this dictionary into a data frame by passing to data frame function. And what will happen after this command? This name, age, city will become column names, and these will become column values. Correct, no? When I convert a dictionary to a data frame, all keys will become column names, and the values will become column values, right? Yes or no? You know, right? Uh, both of you?
Yes, we all good.
Yeah. Okay. So when you want to convert or create a data frame, one method is converting a dictionary to a data frame. And when you receive the data like this, we can also convert sometimes into a data frame by using the data frame function. And another method to create a data frame is I can load the files with the respective functions. Like for example, the read underscore CSV is a function to load any kind of CSV, which is like a comma separated or type separated, or it can be a tab separated also. So there is a type called TSV also. Sometimes when you receive the data with the tab separated values, you can also load them. And if I want to load an Excel file, pandas already have a function read underscore Excel too. I can load a specific sheet in Excel also by passing a sheet name too. Anytime you want to connect to database, we can use the read underscore SQL underscore query function is there. That will help us to load any data that is available in a database table and create a data frame by using the database connection details. Here the connection can be any database connection. It can be Oracle or a SQL server or MySQL, Postgres. The connection should be established. So for that, I need to use the respective database library also, PyMySQL, PyMSSQL, or for the Oracle, CX underscore Oracle library. For the Postgres, PsychObj2 is the library. So we need to load them, import them, and create a connection. And we can, once after my connection is established, that connection object should be used here. Whatever you see, this connection. And query is nothing but is a string which will store the SQL query that you want to execute using this connection. So once after my query is ready and the connection is ready, I can extract the data directly into a data frame here. So this is going to help us not only loading the files, it can also help us to load a database specific table information also. All the database table rows and columns will be automatically loaded into this particular data frame with name DF. And once after my data is available in the DF, I can do whatever the manipulation I want. I can I can go and read the top 5 rows and bottom 5 rows by using the head and tail. The tail and head will give the top 5 and bottom 5 by default. If I want to go and get only a specific number of rows, like 3 rows, I will mention like 3 here. These are all the common functions to inspect the data once after you load it, just like a validation, to see whether all data has been loaded or not, just to cross check. And we have functions like info and shape. Info is going to provide the summary of the data frame. The summary in the sense, what is the data type and what are the columns and the corresponding data types, whether it is a null or not null value, how much memory usage, how many number of variables are there by type, float variables, how many are there, integer, how many are there, string, how many are there. It will give the full summary of the data frame. Whereas shape is a attribute which will, because there is a difference between this and this, correct? No, this is a function because parenthesis is there, but this is not a function. This is called as attribute. A attribute is specifically used for getting the metadata of the data frame. A shape is basically one of the attribute to get the number of rows and columns. The total number of rows and columns will be provided by the shape attribute. And there are other attributes like columns is one attribute to display only column names. Values is going to provide us only the rows. So we have so many attributes like index and attribute. So we have like a size and attribute. All these provide the information about the data frame, the metadata. And when you see a parenthesis, you need to consider that as a function. There is no parenthesis, that will be attribute. Here, describe is also a function to provide the fundamental descriptive statistics of the all numerical columns of the data frame. For our data, we have age and salary, only 2 columns are numerical. So it is providing the fundamental statistics information of age and salary, where how many rows are there for the age and salary, 100 age, because sometimes if there are missing values, this will reduce. Assume I have for 2 rows, the age value is null. So my count will be 98 here. For example, for 3 rows, salary is null. So my count will be 97 here. So it will automatically count the not null values, I mean. And the mean is nothing but the average age and average salary it is giving, and standard deviation and minimum and maximum values. So all these will be the fundamental descriptive statistics which we can collect and review the data what we received as in the data frame. And when you are accessing or selecting the columns, there are different ways. So I can use a data frame name, and then in the square bracket, I clearly need to mention the column name to extract the data. This is called indexing. Indexing is basically here we are using by column name. If you go to list and tuple also, you will see indexing and slicing. So indexing is an operation which will allow us to extract the data by a position, like numerical position generally in the list and tuple. But in case of data frame, we go with the exact column name as an index. Age is a column name, so I will get all the ages into this ages variable, one column. That will become a series by default, because any one column we are assigning, that will by default will be a series. And if I want to get multiple columns, I need to pass those column names in the form of a list. I want to go and get name and city. So 2 columns I want to extract. So I am enclosing again with one more square bracket. So that will be treated as a list of names here, list of column names. So name and city I am extracting. So this name and city will be extracted and will be loaded into this particular subset variable. That also will become another data frame. And label, so label and then position, index. We can use the label based indexing by using the LOC. the locating the data by label. Label means the column name. So here, what this is going to do, the data frame dot loc is giving me all the rows, colon means, and I am extracting only name and city. Two columns, but I am extracting colon here represent all the rows. But the same thing can be achieved with ILOC also. When I am using ILOC, this column names will be replaced by column positions, index. That's what we are doing here. I am using ILOC here. When I am using ILOC, I am giving the row range and column range. I want to display the columns from range from 0, 1, 2 here and row range from 0, 1, 2, 3, 4. Here 5 indicates I want to display up to 4. It will exclude the fifth index. 3 means I will see the first 3 columns 0, 0th position, first position, second position. Here 0 to 4th. So 5 means it will not go up to 5. It will go up to 4 only. 3 means it will go up to second, not the index with 3. So that is how you will need to select the data with LOC and ILOC. Do you know all about this? Nothing? Jahanavi, you know this ILOC and LOC? Did you use them by any chance?
Yes, yes.
You know, right? ILOC, LOC will locate the
Yeah,
data.
yeah, I
And
know.
there is a difference between LOC and ILOC too. So ILOC will go with index and it will not go and consider the end position as it is. It will exclude this particular index and it will go up to 4 only here. But here up to the second position. So generally Python index operation will not consider the end position and it will exclude that. That I hope you know already. And coming to like filtering. So filtering data is a little bit like easy only in Pandas where we use the data frame and a column name in square bracket and we will try to apply the filter. So I want to select all the users for whom the age is greater than 25, all people who are older than 25. So this is the condition I need to mention. The age greater than 25. I want to see all users in the New York location. So df of city equal to ny. So I will get all the people who are matching this condition for all the rows for which this is true. Those will be extracted and will be loaded into this ny users variable. So this is basically how we go and filter the data by using the Boolean indexing, we call it as. And apart from that, multiple conditions also you can mention. This is how you will filter the data with multiple conditions. So here, I want to extract all the customers who are older than 25 plus who are living in New York. So this is basically going to give us that both the combinations. And I can push the final result also into a result data frame also. So simply this filter will be replaced by this. And this is going to extract whatever that data that is matching these two conditions, that data will be extracted and pushed into the result data frame here. And this can be achieved through some other function also. Do you know what is that function by any chance? Instead of using this one, I can use one more function which like a database method. What is that?
Where class is it? Because I used in PySpark using
Correct. But
.SQL.
correct. But in Pandas, we have a function called query. The query function, I can simply use df.query in the bracket in double quotes. I can mention age greater than 25, comma city double equal to New York also. I do not even need to use this method. Simply I can use df.query in the bracket. I can mention like a database condition, where class condition. I do not even need to use df of age. Simply say age greater than 25 and city equal to double equal to New York also. That also will be the same output. That is basically a SQL kind of method. Are you getting right? Both of you. So the query function will try to behave like a SQL query.
Correct, correct.
So I can use that because most of the SQL developer will prefer to use SQL query because this also will be easy only, but that will be a little bit easier than this.
Yeah.
Because if you have multiple conditions, you may sometimes you will feel this is a complex. The number of conditions are more, you feel this is complex. So again, I need to go and add multiple like parentheses, everything I need to clearly cross check. But if I go with a SQL query, I do not need to worry about all these square brackets, parentheses, all this stuff. Simply go and use SQL data frame dot query under SQL condition, simple. Similar to that, when you are willing to handle null values, we have functions available in pandas like drop na. And drop na is basically will go and try to remove the rows which are having null values. And if at all I want to go and drop columns with null values, I will use x equal to 1. Here, what is the default? It should be x equal to 0. If I don't mention anything, it will go by row. That is the condition x is equal to 0. If
Drop.
I Hmm.
Actually, for drop, we will delete the whole entire row or entire column, right?
Correct. That's true. It will do that. It will do that. But if at all you don't want to delete and you want to delete only specific columns, also you can do that by using this one x equal to 1. Because that is not a good practice, right? Removing a column because data should not be deleted. Either you need to replace or at least you can delete one or two rows is fine, but the entire column you remove, you are losing some data. So always the best choice is try to replace with some meaningful values and use it because data is very important. Customer data whatever you receive, and sometimes you need to fill with some values instead of removing. I will fill with 0 wherever
Yeah.
I have null values. Instead of removing that, I will replace with 0. That will be okay, right? Generally.
Correct.
So that is called imputing missing values. So filling means in the traditional data analysis, people call that as imputing missing values. If any numerical value, if at all I want to go and replace, sometimes people replace with 0. Sometimes people also replace with the average of the column for numerical values. Here, that's what you are doing. I am replacing wherever null values are there. I am simply replacing with what? The average age, correct? No? And if I go to any categorical data, I replace with the mode. Mode, what do you meant by mode? The most occurring value. If I say, for example, assume I have gender column. The gender column contains M or F, but some rows it has null value, NA. So how can we go and handle that? We need to replace wherever null values are there, use fill NA and replace with the most occurring value in that column. Assume my most occurring value is male. So I will replace the all missing values with the male. If my most occurring value is female, I will replace with female. So these are the traditional practice people follow to avoid deleting the data. So this is one of the best practice which you have to do because instead of removing data, replace the values, fill the values. That is what we have to understand. And the duplicate removal also. We have drop duplicates is one of the function which will remove duplicates from the data and some other scenarios you may see the data may be having so many rows, but most of them are duplicates. So to remove all the duplicates, simply call data frame name dot drop duplicate. So that is going to remove all the duplicate rows and only keeping the first occurrence by default. If my data contains out of my 100 rows, maybe 10 duplicate rows. So it will remove all the remaining 9 duplicates and keep only one. So my data out of 100 now will become 91 rows. So the drop duplicates will try to remove the duplicate rows and keep only the one row out of them. And renaming the columns also. Sometimes you rename the columns also, right? So I don't want to keep the existing columns from the file, because sometimes the column names also will not be looking good. We need to make it readable. So here, age, I'm converting into years, renaming to years, and city, I'm replacing with location. Renaming with location. So according to your requirement, you may need to rename the columns also. So to rename, we'll use the df.rename, and which columns you want to rename, you will pass that as a dictionary like this. And new columns, how we can add is very easy, very straightforward method we can use to add a new column. Simply use data frame name, and in single quotes in square bracket, whatever the new column you mention, that will be created as a new column. So pandas is very liberal. It will simply create a new column if it is not available. If it is there, it will replace the value. If it is not available, it will create the column. So that is the nature of the pandas data frame operations. And existing ones will be replaced, and the value, the row which the column does not exist will be created. That is how which we need to understand. And we have like group by also aggregation. So this aggregation is basically will happen generally with group by function, but when you are applying this group by, you also need to see what summary you want to perform, whether you want to take an average or a total salary here, and the average age here, average age we are calculating, mean means. Total salary I'm calculating by department. So these particular functions are almost similar to our database SQL functions, and we can use the same here also. I hope you already know all this, but I'm just refreshing, okay? And coming to like value counts, this value counts is one of the popular function for creating a frequency distribution. I want to see by city how many rows are there total. So for example, by New York, how many rows? Like that, I want to see Chicago, how many rows? Los Angeles, how many rows? So if you pass the city column with value counts here, it is trying to give the summary of each city. 50 people are there in New York, 30 people are there in Los Angeles, 20 people in Chicago. So it is calculating the number of users per city, total number of users. So value counts is one of the function which will take the categorical data as an input, and it will provide the number of occurrences of that particular category. So just like our group by function in SQL, how it is going to group by a particular data frame, I mean some column. And arranging the data in order. Sort values is a function to arrange the data in the ascending or descending order. But I clearly need to mention ascending equal to false if you want to sort in descending order. If you don't mention, the default is ascending. So ascending equal to true is the default. And here it is by default, I did not mention anything. So it will consider as a default ascending order. I hope that is clear.
Yes, all good.
Yeah. So did you use this, Janavi?
Not in pandas.
Yes.
Okay, so this particular maybe you might have used in PySpark, but the same almost same functions, right?
Correct.
If you go to pandas, these functions almost whatever you use in pandas all are same in PySpark also, but PySpark is
Almost,
yeah. Additionally, it will provide some other operations like Spark SQL and RDD operations. These are all additional.
yeah.
So if you know pandas, the data frame operations are almost same in the PySpark.
Correct.
But there might be some additional functions, but almost 80 to 90% whatever pandas will provide us, PySpark also will provide us. But the only difference is the distributed computing we can experience in PySpark.
PySpark, yeah.
Pandas is having some limitation on the like number of rows and all, the data volume is too high, I cannot manage. So in that
Right.
scenario, I move to PySpark. So that is the reason why people also prefer PySpark other than Pandas. If they want to go and manipulate, the data is too high and not able to fit in the Pandas data frame. So we go for PySpark data frame to manage it. And now that I can easily manipulate it because we have a compute, more compute in Databricks. For example, if you go to Databricks, we have in the platform, we have a cluster. We can get a cluster compute. So that compute can help us to manipulate any amount of data according to the cluster capacity. Correct, no?
Perfect, Shikhar.
Yeah. So all these generally, as a data engineer, you do on a regular basis. Either you use Pandas or PySpark, your data which you are going to manipulate and make your dirty hand that your hands dirty, that is very important because you don't know what kind of issues will arise on a particular day. My data may give me in any kind of errors, but you need to know what are the different ways to clean it first of all, and how to transform the data. For example, whatever you see now, I'm just trying to convert my name into uppercase here. I'm using a upper function to convert it. And contains is going to give us to verify whether partial sets, whether that particular substring is present in that my main string or not substring. And replace is going to replace a particular string with another string. So all this basically will help us in most of the string operations. And coming to like these are the basic data frame operations which generally pandas will allow us. And when I talk about like other operations like merge is there. So do you know what merge will do generally?
Yeah, combining two data frames, right?
So I can combine.
Yeah.
Merge will combine by common row, sorry, common column joining. But if at all I want to implement a union, there is one more function. What is that? Any idea? Concat. So concat is a function that will combine the data by two data frames by row or by column also. But if at all I want to join by column, I need to use merge function. But I simply want to only append one data frame to another data frame, the rows like union operation, I use concat function. So the pd.concat pass the two data frames. Then it will combine by row by default. Assume I don't want to combine by row, I can even combine by column. Then I need to use a parameter x equal to 1 to that concat function. Then my rows will be added as columns. I'll show some examples. Maybe you will get some idea.
Mm.
So generally, you might have seen Alt Anaconda Navigator, right? This is one of the tool for Python development and all. We have so many tools inside Anaconda Navigator which we can use to build your code. But coming to like PySpark notebooks, I can even use PySpark notebooks also, like database notebooks also to run the Python code and PySpark code as well. But here, Anaconda Navigator will provide different tools to develop your Python code. Like Jupyter Lab, VS Code Editor, and then Spider. We have different tools available in Anaconda Navigator to run your Python code. So Jupyter Lab is a collection of Jupyter notebooks which will help us to manage multiple Jupyter notebooks. So the Jupyter lab. Yeah. So here, whatever you see, these are all like pandas operations. I'm just importing pandas, and then I'm loading one particular CSV file into a data frame with name empdf, and then I'm manipulating the data with different functions here. So empdf is my data frame, which will be created, and I use this empdf for my further manipulation. So this is going displaying me the total number of rows and columns here, 1000 rows and 8 columns. To get my 1000 rows and 8 columns, I can even use the shape also. Shape is one function, one attribute that will provide me how many rows and columns are there. And we discussed about head and tail, which are going to provide the top and bottom rows. I am getting top 8 rows here, and the tail give me by default bottom 5 rows. But all I want to go and only 3 rows, I'll mention 3 here, which will provide me bottom 3. As I mentioned, the shape is going to give me, the attribute give me how many rows and columns are there, 1000 rows and 8 columns.
Mm.
And I can get the number of rows using len function also. If I pass the entire data frame name to the len function, this also will give me the total rows. So total rows I can get with this method or this method. I can also can see total rows here also. So there are many different ways to find out how many rows are there. Similar to that, the columns is an attribute which is displaying as only column names. The two in the form of a list. And if at all I want to see only rows, I use values attribute, which is giving me only values like this. And the D types is giving me the attribute, the column name and corresponding data type. And in pandas, the string will be treated as object. Integer will be treated as int64, float will be as float64, like that. And coming to like other attributes, we have like number of dimensions to size 8000 and axis, and what is the starting and ending like index, all we can get by using axis. And apart from this, to extract the columns, we can use the square bracket method. This is one way. I'm extracting only these columns out of my 8 columns, and we are rearranging the columns here by leveraging this particular list of column names. and this is giving me only the column names I want. It is not giving us all the column names, but top 8 rows. We are redirecting the output and passing to head function to display top 8. Similar to that, I can get in between rows also. I want to display the rows between 450 to 500. So I'm getting first the top 500, and from that I am getting bottom 50, which is 450 to 500. This is one way how to get the in between rows. And coming to like other functions, this is one way to filter the data, right? Which we discussed about. So multiple conditions I'm giving here: gender equal to male, and the team equal to product, and who are on the senior management, and the salary greater than 100,000. So 4 conditions I'm giving here, but all these 4 conditions, it has to match and get the data according to all the male employees under product team and who are under senior management, which is true, and then salary greater than 100,000. You can see here this column. Only these are the employees who are meeting these conditions. But the same output I can achieve like this also. A query function, gender equal to male, team equal to product, and I'm adding the senior management equal to true, and I also want to add salary greater than 100,000 also. Then I add one more condition here and say salary greater than 100,000. So this also will give the same output what you see here. So both are giving the same output, but in different ways. You can see here. So both are same, right? But this is with query, and this is with the double square bracket and open close parenthesis. We are adding the conditions and getting the data. So like that, we can get the data, filter the data using query function and this double square bracket method. And apart from this, LOC and ILOC, what we are trying to do here? We are extracting all the rows, but I want to display from first name to last login time. So first name, gender, start date, last login time, it is displaying. And out of that, I'm only getting the male customers, so male employees, I mean. So that is what we are trying to achieve here. So the output of this command, we are passing to query function again and get the male employees information. And what I'm getting here, I'm trying to get a particular row here, but all the rows I want, sorry, 141 to 145, but I want to display all the columns, but I don't know why it is not displaying. Yeah, I got all the columns, but 141st to 144. It is not including 145 because I'm using ILOC. If I use LOC, I will get 145 also. For example, if I give LOC, it will pick up 145 too. But when I use ILOC, it will exclude 145 because of index. Is it clear? You might have already used them, but these are all the different functions will help us to manipulate the data at Python pandas level. But the same kind of operations also we will do in the PySpark as well, but with different functions. Will you practice this today? Janavi and Prasanna at high level?
Yeah.
I will share this file and the input files also, whatever I have. And whatever the files involved in this particular file, I'll share. Just try to play with it and try to see and how you can manipulate the data at pandas level.
Yeah, super.
Because I want to speed up because I don't want to keep only pandas for some time. So I want you to go and play with it with all what pandas available. And I also try to share the merge script also. You can try that also. Is it clear, Jahnavi?
Yeah, sure.
I I'll share the input files and the script and the PPT. Just try to refer it and try to work on that. Okay.
Awesome.
Okay. Thank you so much. That's all for today.
Thank you, guys.
Thank
Thank
you.
you.
Thank you.
Thank you.